Welcome student in our YouTube channel Physics by TC Chauhan sir. Today we are going to discuss about electric field in lines or electric line of forces. Electric line of forces are those lines on which a unit positive free test charge travel in an electric field. Suppose there is an electric field in which a unit positive test charge is there. So how much it will travel? This is known as electric field line or electric line of force. In other words, those virtual lines on which tangent drawn at a particular point shows direction of electric field intensity at that point. That line is known as, that curve is known as electric field line or electric line of forces. Again, two definitions. First is those virtual lines on which a unit positive test charge travel in an electric field. Second is those curves on which tangent drawn shows direction of electric field intensity at that point are known as electric field lines. Now, what about mapping of electric field lines? There are several kinds of mapping. For isolated positive charge, these electric field lines will be in this way. For isolated negative charge, the electric field lines will be in this way. For positive charge, these are outward. For negative charge, these are inward. For a system of two positive charges, then electric field lines will be in this way. These will not intersect, remember. When these become closed, these will get repaired. So this will be the mode of formation of electric field lines or mapping, you can say, for electric field lines. For two negative charges, again mapping is same, but direction is exactly opposite. This will be the mapping of electric field lines. This is the mapping. Again, direction will be inverse. This will be the direction. It will be inverse. Here there are two regions. This is called neutral region. Neutral region where there is no presence of electric field lines. Now, if there is positive and negative charge like this way, then field lines will start from positive and ends at negative like this. Like this. Start from positive, remember. So this is for a positive and a negative charge. If there is a plate, system of two plates, one is positively charged, other is negatively charged, then electric field lines will be in this way. These will create uniform electric field in between. If field lines are at equidistance, then electric field will be uniform. And if these are not at equidistance, then field is non-uniform. Remember, if these are equidistance, electric field will be same. E1 is equal to E2. But if the places where these are close to each other, then electric field will be high. E1 greater than E2. These are mapping of electric field lines. In such a way, electric field lines can be mapped. These can move from positive and ends at negative charges. There are a few properties of electric field lines. First property is these are outward for positive charge. Second is these are inward for negative charge. These travel from positive to negative. These form open loop. These all are open loops, not closed loop. Remember, these form open loop. These are virtual lines. If these are close to each other, electric field is high. If these are away from each other, electric field will be low. If these are at equidistance, electric field will be uniform. If these are not at equidistance, electric field will be non-uniform. If these are in such a way that these are following particular path and then electric field will be exist, and if these are not available at a particular place, then the region is neutral region. This region is known as neutral region. This is about properties of electric field lines. The important properties: electric field lines never intersect. These can never intersect at all, because at one point we cannot have two direction of electric field intensity. At one point there will be only one direction of electric field intensity. So we can say that electric field lines never intersect each other. This is about electric field lines, their mapping and their properties. Let us discuss about some questions depending upon electric field lines. Question number first: if you have given that two plates are there, one is positively charged and the other is negatively charged, and you have to keep a positive charge in between them, then what will be the mapping of electric field lines? That will be the question, which is very important. The mapping will be in this way. In this way, these will repel positive, positive, in this way, and then like that, like that. These will be the mapping of electric field lines when a positive charge is kept in between two plates. Like question number second: if you are having two plates like this, one is positive and other is negative charge, and a negative charge is kept in between them, what will be the mapping of electric field lines? In this case, the electric field lines will move like that, like that, like that, and then in this way, in this way. This is the mapping. This is also an important question. Whenever positive or negative charges are kept in between two charged plates, then electric field lines in this way. Then question number third: if a metal sphere is kept in electric field, what happens? This is a metal sphere. It is kept in electric field. Then most of electric field lines will get deviated towards the sphere, metal sphere, like that, like that, like that, like that, like that, like that. This is due to induction of electric field lines or induction of electric charges developed at both the ends. Then electric field lines will get deviated at the ends. Then another question is question number 4. Okay, how does a charge can be balanced? If there is a positive charge and we want to balance it in electric field, then direction of electric field must be upwards. Remember, for positive charge, electric field lines must be upward, electric field must be upwards. Then the upper part will become negative, lower part will become positive. Then the mass of particle and charge are Q and M, and then weight will be W is equal to mg. The force will be upward, F is equal to QE. These will get balanced and mg should be equal to QE. So this is an important relation. Two things are there. One is, what about the direction of electric field intensity and electric field lines? It depends upon the nature of charge. If it is positive, then it should be upwards. Then force should be equal to the weight. That W, that is mg, should be equal to F, that is QE. By using this relation, you can find electric field, you can find charge, you can find mass if other three quantities are given. G is given to you, that is 9.8. Now, what about question number 5th? If negative charge is there, what about direction of electric field? It must be downwards. That is, electric field lines must be downward. Electric field must be downward because negative charge is balanced when upper portion should be positive. Then the force will act here, that is QE, because negative and positive will get attracted, and weight W will be mg here. For balanced state, the W should be equal to QE, that is mg should be equal to QE. This is about force and weight. So this is very, very important as far as we concern about the conceptual questions. I think this session become very useful for you. Please do subscribe, share and like our YouTube channel. This is time of COVID-19 or coronavirus. You should stay at home, stay safe, and please study by our YouTube channel and get its maximum benefit. Thank you very much.